Okay, so looking at this one example, we have f of x equals sine x over the absolute value of x. We want to look at what the graph looks like. And so first of all, let's look at a couple of things. I know, and we had talked about the special limit as x approaches 0 of sine x all over x. Recall this was equal to 1. Okay, let's look at the graph of sine x for a second. And I know the graph of y equals sine x. It goes through the origin here. Right, like this. The other thing is that we actually have the absolute value of x. And the absolute value of x, remember, if we have an absolute value, we can rewrite that with the piecewise function. So let's look at f of x is this. So let's rewrite f of x without that absolute value sign. Oops. So I can say f of x is equal to, well, it's sine x, right? All over positive x, or just x, if our x value is greater than 0. If I plug in a number that is less than 0, recall that because it's the absolute value of the x in the denominator, I have to change that sign in the denominator. So I'm going to have sine of x all over negative of x. So now let's look at the limit as x is approaching 0 on the left-hand side. Just curious if this had changed on. So looking at it on the left-hand side, that tells me that I want to use this. Actually, let's just pull out the negative. So this would be sine x all over x. And so we know that this piece is approaching 1. And so we're going to be approaching negative 1. And so we're going to do the same thing now and looking at the limit as x is approaching 0 from the right. Of this sine x all over x. Our values of x are greater than 0, so we're using this first equation. And we had seen that this was a special limit. We were using that to manipulate things to find limits with sine of something over something x before. And so this one is going to positive 1. And so we get, in this case, D. So let's go, this was a multiple part question. So let's look at what the next piece says. So the second part of this question says, if the graph appears to have a continuous extension at x equals 0, find a good candidate for the extended function value at x equals 0. If the function does not appear to have a continuous extension, can it be extended to be continuous at x equals 0 from the right or left? If so, should the extended function values, what should they be? Select the correct solution below and fill in the boxes as needed. Well, first of all, I know that, well, we saw that graph as we were coming in to 0, we were getting closer and closer to -1, right? But it was undefined there. The other way, as we're coming in over, as we're getting closer and closer to 0 on the right, we're getting closer and closer to 1. I know that this is not a removable discontinuity. There's not just one value of X that would make a solid circle there and make that so there's no jump. I'm actually not familiar with this extended, but what I've gotten that it means is, can we say, okay, can we make this just continuous if we're talking about coming in on the right-hand side? So let me just start reading through and we'll exclude as we go through. So the function can be extended. The extended function value at x equals 0 as f of 0 equals, well, that's not going to work because there's not just one value of x that would work at x equals 0. The function cannot be extended to be continuous at x equals 0. It can be extended to be continuous at x equals 0 just from only the right if f of 0 is this. I think we can make it continuous both on the left and the right, but we're going to have two different things. So let's see. C, the function cannot be extended to be continuous at x equals 0. It can be extended to be continuous from the left if f of 0 is this. I believe it's D. I think we can choose different x values, y values. The function cannot be extended to be continuous at x equals 0. It can be extended to be continuous at x equals 0 from the right-hand side. If we choose f of 0, well, on the right-hand side, we want to choose f of 0 to be 1. And on the left-hand side, we want to choose our f of 0 to be -1.